Okay, round two. New and improved telescope layout. And the people who are here right now, you are my guinea pigs. Guess I chose Halloween because I knew that nobody would watch it. Everyone's going to be busy. Nobody's going to want to check this out. I have a YouTube logo right on my face. Yeah, same scope. I don't know. As long as we're having fun, I guess. No rhyme or reason to this. We'll go for as long as we all want. Yeah, this is the Veil Nebula. So I figured I would, that's the Western Veil. We're doing the Eastern Veil. This is just the beginning. This is not back. This is just testing because we don't have other telescopes, other astronomers, special guests, all kinds of good fun. This is just me testing this one telescope by myself. But at least we made a nicer layout that gives more room for the pictures. Um, so for if any of you are wondering what it is that this is, I am operating a live telescope remotely in Texas, and I'm gonna be your DJ tonight. No, not a question show. Um, we're gonna go and image a whole bunch of stuff in the night sky, and till we're sick of it. David Dunn's here. Hey, David. Man, blast from the past, huh? Um, so it's good seeing tonight, and it looks like there's some like cloudy weather coming. So we will try and get this, try and get as much observing tonight as we can. So the name of the telescope is up in the upper left-hand corner. So it's a Celestron Origin. Then located at Starfront, which is in. This is the look at M83. Well, it's an M83, maybe. And so now we're doing an image of the Eastern Veil Nebula. You can see you can see that it's gathering images. So I've done a 90-second exposure so far. The moon isn't up. Good, gladly. The moon is awful. Nobody likes the moon if you're doing astronomy. Right. So this is like something that's going to take a little bit longer exposure, and we'll do some quick exposure stuff. And Arjun. So that's a 2-minute exposure, and I think I'm starting to see the nebulosity in the Eastern Veil Nebula. So clearly these kinds of images want more like a 5-minute exposure. Although I can change, I can change the ISO. So I'm gonna do a bunch of experiments. I have no plan, no set schedule. The improvement that we have tonight is it says Andromeda M33. So I've got here, that is the can actually change it. There we go. Boom, quickly. Yeah, so we're gonna try a bunch of experiments. Hey Ben, no problem. Yeah, so we'll try a bunch of experiments. We'll see what you guys like, what you're into, and then I've pinned a thing at the top of the chat, which is a Google Drive share to all of the images that we're sharing. So, you can just download the images as we create them. All right, that's enough of this. And the image. And then, what's been added to the drive. And You can download it. And I will download it. Good. Also, let's do Andromeda. Right. So the image has been down. So if you go to that, if you refresh that folder that has the list of images in it, should have the image, and then I will share. Cool. So I can kind of move it around a bit. So this is the Veil Nebula. This is the Eastern Veil Nebula. And the Eastern Veil Nebula is a remnant from a supernova that detonated this giant ring in the sky. This is one of the kind of fronts of this expanding cloud of gas and dust left over from the nebula. And the thing is so big that it requires multiple telescope views to be able to see the entire. This is just one chunk of it. Yeah, we're just doing more tests, but it's like a little fancier tonight. Do M33. No, yeah, we'll do M33 first. So now moving the telescope to M33, and this is the galaxy in Triangulum. This is the second closest large galaxy to the Milky Way. The closest galaxy, of course, is Andromeda, 5 million light years away, and is on a collision course with the Milky Way. And in, I don't know, 7 billion years, the Milky Way and Andromeda are going to collide into which I like to call Milkdromeda. Others disagree. They're wrong. It's Milkdromeda. But also M33, this galaxy will also be added to the collection of galaxies. They'll all turn into this giant elliptical galaxy, as well as all of the dwarf galaxies that are all surrounding us. And that's it. That's all that the local group is gravitationally bound. So even though there are lots of other galaxies in the sky, they're going to zip off over the cosmic horizon. They're being carried away by the expansion of the universe and dark energy. Yeah. So I'm not going to answer like taking pictures related questions just because I fractures my brain. Maybe, who knows? So what's cool about this is you can't see the galaxy, right? This is kind of like what I like about this imaging system is that it shows you what you would see with your own eyes. It sort of like has this live view, and then it does these 10-second exposures. And now you can sort of see the galaxy showing up in the image. So now we've done one 10-second exposure, and now the telescope stacks up the exposures one after the other. Each new image that comes in, it gives it more data, and it learns what is the noise. And so you just get a higher and higher quality image over time. And so we can just let this run for as long as you have patience. It's funny because the last time I was doing this, people like, oh, you should do a much longer exposure. But, for a while, we're just like, I don't know, we'd be like staring at pictures for, I don't know, an hour watching this thing build up. And, after a while, you don't get a lot of increase in data. So, but yeah. Thanks for coming by, Ellen. I know it's a total surprise. We're doing astronomy, but I will, you'll get more notice in the future, and there will be more people. So it's going to be a bit more of a party and less of just me sharing the live view scope. So what's cool about the M33, also known as the Pinwheel Galaxy, is that it has one of the most extreme star clusters that we know of. It's got a just like it's got one section. I don't know if we can see it in the picture, but some of the most massive stars that have ever been found are located in this galaxy. There's a story we did on Universe Today about this, where um, they were viewing this galaxy. They were actually tracking stars as they were throwing each other out of this giant star-forming nebula. So I have to get a sense of. I mean, I guess I have to use my judgment about when I've had I think it's a long enough exposure. But I mean, we can do these things that's a 2-minute exposure now, 130-second. But I think this gives the gist of it. I'll stop this exposure. And then once again, the image will save into the Google Drive and you can access it. But I'm going to try changing the ISO. We'll see if because the ISO will mean it should make for like a much faster image, but it'll probably be a little grainier. Try that out. Never actually done. It'll do a 2000 ISO. What that does. Yeah, and the image is there. Okay, so we'll compare. Doesn't seem a lot different, even though it's a 2000 ISO, so it's a much grainier, faster, low light image. Actually, don't think it. Yeah, I'm gonna stop. No need for that. I mean, I'm gonna discard it. Go back to the 200. I don't think there's any filter on the telescope. They have a light pollution filter that they can put on this telescope so we can do imaging even when the moon is out. So probably have to do that soon if we keep doing this. Okay. Let's do Andromeda now. So that was M33 in Triangulum. Now we'll do Andromeda, which is that other big galaxy that I mentioned. You see how they're kind of close in the sky? You see Andromeda, and then we were at the Pinwheel Galaxy, and now we're going over to Andromeda. GC 2683. Maybe. I mean, the ISO, like, it's just a camera, and the ISO works exactly the same way that the ISO works digital camera or a video camera. I don't exactly know what ISO is the equivalent of the film grain, right? The speed of the film. Yeah, there you go. It's turning up the volume when they only have the 3 settings. So they only have 100 ISO, 200 of Andromeda. Again, this is the best galaxy that we could, apart from maybe the large and small match. We can't see them from where the telescope. Now we're back to the 200 ISO. So you can see that first shot is very grainy. And then as soon as it starts to image in that second shot, start to the blacks start to get better. But even like the core, like what's incredible to me is even in this image, as it's starting to build, you can see the dark dust lane around the core of the galaxy. There, that made it a lot better. You can see those dark dust lanes. And that's the kind of thing we'll go and look at some dark nebulae tonight, and you can see examples of this that we have here in the Milky Way. But this is one that is in a completely separate galaxy. So the telescope, it's Celestron Origins. It's a smart scope, so it does its own guiding. It actually does its own plate solving, and it has GPS built on board, and then it finds, as soon as it can see the night sky, takes a couple of images of the night sky, and then plate solves to figure out where it is oriented. So, if you've ever owned a telescope in the past and you spend all this time trying to polar align it so that you can get it all nicely lined up so that the go-to mechanism of your telescope works, like this just handles it all automatically, which is amazing. Adam Shup, would it be possible to have a webcam pointed? Yeah, there actually is a webcam that is ready to be installed. Probably the next time we go live, we'll actually have a webcam pointing at the telescope, so you can actually watch the telescope moving around with the view to the sky behind it. Yeah, so Alan, you're saying that bright dot to the right of Andromeda is also a galaxy with an N number. Can you get a picture of it? Well, that's the picture. Like, that's the field of view of this telescope. So, I don't think I could take a better picture of it than this. All right, I think that's good. I'll stop this image. And once again, the image will pop into Google Drive. Yeah. Yeah, I mean, anyone who's ever owned like an old school telescope. When it's downloaded. So someone asked for IC342. Oh, okay, the picture should be downloaded. That is. Yeah, you should definitely go to NASA and download their picture. It's much better. We could do that as well. We could just like look at pictures taken by the Hubble Space Telescope. But I think there's something kind of special about actually taking the picture. All right, so we'll try the IC1. Probably pretty small, its field of view. See it. Maybe that's it there, right in the very. It's a very large field of view. Yeah, I think this would take a much longer exposure. Once I download it, I'll be able to zoom in on it. Orion Nebula isn't up yet, but in a couple of, like, it would be if I stuck around for a couple more hours. But actually some of the summer stuff is still up, which, like the Omega Nebula, Trifid. You can try grabbing some of those. Yeah. But Pleiades is up. That's always a good. I think this is the best we can do. I mean, I'm sure if I just let this run all night. I'll try to download. Yeah, the Lagoon Nebula. Let's do the Lagoon right now. Before it sets. Checking it. Maybe it is. No, the Eagle should be okay. Let me try. Telescope may. There's IC342. Yeah, like I can just see a little bit of the spiral arms there, but this wants to be a 10-minute exposure. A little out of focus too. I'm just zooming in on the image on my local computer. This is great. So this is actually very close to the core of the Milky Way part, yeah, of the sky. It's still, stars aren't really crisp. Ryan is up for John. Yeah, he's in Europe. As you're seeing, John. All right. So now you can already see the pillars of creation. Right there. Hubble does it better. James Webb. Any quasars? There's probably quasars, and this telescope could probably capture a quasar, but it would just look like a star, like a very like. I can tell you that 1,000 of the stars in this picture are actually quasars. Just so faint. Yeah, when someone sets up a zoom in and out image of Euclid, that'll be good. Yeah, people will be happy. Thanks for the donation, Nomadic Synth. Do another couple of seconds on the pillars of creation. Then we'll, I don't know, like line it up to the one taken by Hubble. Yeah, I can't wait for Orion to come up. The Horsehead Nebula and the Flame Nebula. There's a lot of good stuff. Yeah, quasars in Virgo. There's like the closest, brightest quasar, but the kind of and like the forget the magnitude, but it is like 11 or something. It is capturable by this telescope. You know, I could take a picture of Neptune. We'll do that. You'll see it's just a little blue dot. That's why they're, quasar, quasi-stellar objects. When they were first discovered, they just look like stars. It's just that they were very highly redshifted. Okay, that'll do. I kind of feel like I need to focus the camera again. Over to the Omega. Close. I hope that it goes all the way over there before it comes back to the Omega. This is pretty much the lowest this telescope can go. Any lower is the horizon. Hey, Visto Tootie. Surprise. Hey, new available? And this is so much smoother than the first test that we did a couple of nights ago. Okay, there you go. Zoom in, zoom in, zoom in and enhance. So that's the, remember, thing's the name. So this is the Eagle Nebula, and these are the pillars of creation right here. I don't know if you can see my little hand, but if you sort of go and look at the Hubble version, you can see that it's the same kind of shape. And so what this is that, let me start taking a picture of the, okay, of Mega Nebula. So what you're looking at is right at this point here, there's like a new, like this is a star forming nebula. This is all gas and dust that's forming a bunch of the new stars. And a lot of them, you can already see a bunch of the new stars that formed in this region. But then these are regions where the stars are still forming. And right here, you've got a star that's surrounded by a sort of cloud of gas. Like it had pulled in all of this gas and starting to form at the heart of it. And then you've got these bright stars here, and they're putting out radiation. And I don't want to do it, but I can draw on it. So these bright stars are pumping out radiation, and the radiation is kind of acting like a wind that is pushing against. Here we go. Try this. Okay. This is going to be sick and wrong, but I want to try it. All right. So we've got these bright stars here. And they are blowing a wind this way. And then you've got these stars that are inside little cocoons of gas. And the wind is blowing away this material this way. So cool. And now I can just move this. Boom. Back. Okay. While we were talking, the Omega Nebula is being imaged. Look at that. Pleiades is up. I'll try. I've never pressed the focus button, so let's give that a shot. We can definitely point it at Betelgeuse when Betelgeuse is up. There's Betelgeuse. Can focus it? Let's try. Autofocus. Never done this before, so I have no idea if this is going to work. All right, the new image is downloaded. Sounds great. Tell you a story about the 15-year-old years ago talking about the youth today. So 15 years ago, 2012, right? So we started doing the first star parties in 2012. So 13 years ago, 12 years ago. That's kind of amazing. All right, so let's see if that helped. Let's go to Pleiades. M45. Yeah, I should have done a refocus when the temperature changed, because the changing temperature changes the optics a little bit. Going from daytime. And I haven't seen the nova yet, but I can show you where the nova will be. Oh, we can go look at the Hyades cluster. uh, with the Fraser 2012. Think about the Fraser. I don't know. I've been doing the same job. Been doing the same job for 25 years now. I'm going to remove both the noise suppressors, Anton. Okay. So I've been doing the same job for 25 years. Different versions and variations and flavors of it. But, like I think for me, in the olden days before doing Universe Today, I worked for software companies. I worked in the business field, software development, things like that, and didn't enjoy my work very much. I liked it, but and so I think for me, it was always, I realized that the kind of work that I need to do is about following my own curiosity, about investigating the things that I'm most interested in and figuring out how to make a career. I mean, I'm so lucky, right? Like I get to just talk to interesting people about the work that they're doing, which is awesome. So, yeah. I ran autofocus. So let's see. Fraser's going to own this timeshare telescope for life. They actually set up the telescope just for us. So we have solo use of this telescope. And they are going to be adding a second telescope in a couple of weeks, right beside this one, which is going to be a planetary scope. So we'll be able to then look at Saturn and Jupiter and Mars and Uranus and Neptune and craters on the moon and things like that. So this is just the beginning, but I think they're, thanks to Starfront for providing the service. This is incredible. I'm so excited. IARC I'm a software developer. Haven't felt burnout enough to lose the passion yet. So the thing for me was that I had tons of ideas. Like I'm an idea guy and I had lots of really creative ideas. And my clients were like banks and power companies and things like that. And so I had all these what I thought were really good ideas. I understood the internet, back when it had just, when the World Wide Web had just launched. And my clients were just too nervous to try some of my crazy ideas. And I just found it really frustrating to have what I thought were going to be really successful ideas and that they weren't going to listen to me. So I much prefer to create content for the end audience as opposed to having to create content for a customer who then is trying to create content for the end audience. So, okay, let's stop with the Pleiades. Now I have to get the spelling right. Unfortunately, the field of view is a little too small to show off the whole thing. Okay, the new image has been downloaded to the drive. Oh, great. Thank you for, I'm glad you're enjoying the videos about web. Yes, I did work for the X Prize. I helped design the, I was the product manager for their sort of web version of their prize system for a company called HeroX. Yeah, the focus made a huge difference. See, here's the Pleiades. And the stars look great. And whatever that red thing is there. That's nice. That's really good. You don't have to be here. You should be in bed. I guess you are an amateur astronomer, so you can't help yourself. So there you go. So the Uranus is right there. Let's take a look at Uranus. So it's just going to be a tiny blue-green dot in the middle of this image. There it is. That's cool. So this is why we need the planetary scope. Although, like, it's not going to look a lot much better in even a planetary scope. Like, you really need something, like the Hubble Space Telescope. All right, that'll do. I wonder if I can see one of the moons there. Okay. Let's give it a second. All right, so let's try T Coronae. No. Oh, that's Australis. I want Borealis. Yes. Okay. Oh, it's below the horizon. Wah, wah. Okay, let's do M13. Oh, all right, let's try Uranus. Do you see it? Oh, nay. Jupiter, I think, is still below the horizon, but Saturn is up. I'll check. Man, you can already see the cluster there in the image. Oh, M1. Yeah, let's do the Crab Nebula. Okay. If it's above, if it's like above the horizon. So I love about this is I could just do a 10-second exposure, maybe a 30-second exposure, and we're done with the Great Cluster in Hercules. And this has, there's 1 million stars in this cluster. On average, they're about 1 light year apart. So if you lived on a planet inside orbiting one of the stars in this cluster, it would just be like daytime all the time. Jason Hildebrand, Jupiter, Miranda has liquid oceans. They found something wet and warm around Uranus. Yeah, people are having a field day with that. We just recorded Space Bites a couple of hours ago, and we covered that story about the discovery of an ocean underneath Miranda. And I was like, oh, do I want to make a joke about it? No, this is the week I don't make a joke about it. I'm sorry. You're welcome. All right, so let's see if we can find the Crab Nebula. Rises 2129. So I don't think it's going to be... Nope, too low. All right, let's try Jupiter. $21.11. So same problem. It's not going to be... Yeah. Too low. So let's do Saturn. So we'll have to wait for a couple of hours. I can do any cool time lapses. I'd like to, not with this telescope. This telescope is terrible at doing planetary stuff. So the Jupiter, you'll see what Saturn looks like. Jupiter will look a little better, but not a lot better. Oh, right. Let me bring up M13. And this is the kind of object that you can see with a pair of binoculars. Clusters. That is so great. What an amazing object. All right, we're looking at Saturn. So in order to do this, I have to take a snapshot. I'll capture an image. 5 millisecond. Yeah. I think it's saved to my camera roll now, so I got to turn the snapshot mode off. This is just not the... I don't think it saved it. Yeah, I don't think it saved it. Weird. Let me try again. Yeah, we'll do the Ring Nebula, which we can zoom in pretty nicely. So it should look good. It's not saving it. Yeah, it's not showing up on the drive. Okay. Okay, we'll do the Ring Nebula. Whoops. Don't press that button. Uh-oh. Whew. Okay. So we'll do the Ring Nebula. M57. And then we can also do the Dumbbell Nebula as well. It is very small. So, but I can zoom in on the image and you can see the color. Yeah, M27 is the Dumbbell. It's bigger. It looks better than the Ring Nebula. But the Ring, so I have so much nostalgia about the Ring Nebula because this was one of the first objects that I looked at with a telescope that I bought when I was 14 years old. And was out every night with my telescope looking at Saturn and looking at Jupiter, and I could see the Ring Nebula, and it's yeah. It looks like this little ring, this little smoky ring in the sky. Yeah, I don't think the Helix Nebula is up. Yes, I have lots of disk space. Well, I don't have a lot of disk space on this Google Drive. I might have to, I'm probably going to be clearing images on a regular basis. So don't get too comfortable with them. I mean, there would be, I could look at things that we know are gravitationally lensed, but we wouldn't see the gravitational lensing. Say you're standing out by the telescope, pristine dark skies. What's the dimmest object that you could see naked eye, and how would that object look through the telescope? I can give you an example, actually. So let me just let me move out of the snapshot mode. Oops. Okay, so I don't know if you can see the ring right there in the middle. It's very tiny. So we won't have to take a lot of exposures because it is very bright, but it's very small. And then I'll download the image and then we'll zoom in. IC59, we can check out IC59. There. There's like a little bit of motion. So let's take another shot. I want to get a clearer shot of it. Yeah, you can definitely look at Polaris. There we go. So I don't need to do more than, that's a 10-second exposure, and you can already start to see the color in it. I'll do like 3 more exposures. So I don't know if I can track the International Space Station. It's in the catalog for the Origin. So that is one of my goals, is to try and actually capture an image of the ISS live. Okay, that's 40 seconds. That's plenty. And then we'll take a look at it. And we'll go over to the Dumbbell Nebula. Oh, no, I was going to answer your question. So this was Methel's question. So let's do this, because I've got a great image that's a good example. So let's do the double cluster. So under dark skies, this is the kind of object that you can see with your own eyes. Yeah, we can look at Algol. So let me just take the new image that's downloaded. So this is the ring nebula. It's what's known as a planetary nebula. And these are when stars like the sun die and they puff off their outer layers into space. And you can't see it, but there's a central star in the very middle, and which is the remnant, the white dwarf left over when the star died. But every planetary nebula is different. The shape of it is different. And we don't really know why. So one sort of idea is that you only get these planetary nebulae when the star was in a binary, star system. But there's some kind of interaction between the star and some companion star that causes the shape of this puff of gas around it to change. All right, so this is the double. Let me recenter it. There. Okay. And so you can see this. It looks like if you know where to look, it looks like just this little fuzzy bit. And a lot of times when you're in like really dark skies, you don't look directly at the thing that you're trying to look at. You use your peripheral vision. So you sort of look away from what you're looking at, and then you notice some little fuzzy bit. And then when you can like turn your eyes and you look at it, you actually can't see it anymore. But you can see the Andromeda galaxy. You can see M33, that other galaxy that I showed you. And you can see this, the double cluster. You can see Pleiades, no problem. Like Pleiades is actually very bright. All right, let's take a picture. Yeah, so this telescope, I'll show you some of the, like, it's there. It's one of the choices. So this is the double cluster. So this is a sort of two star clusters side by side. And it's one of the coolest things to look at through a small telescope, through a pair of binoculars. Yes, I recommend the 8-inch Dobsonian. And so this is the kind of object that looks amazing in a telescope, looks fantastic in a pair of binoculars, but you can also find it and see it and pick it out with the unaided eye, which is pretty cool. Yeah, you don't point at it, you point where it's going to be. That'll do. All right. So do you want to see Algol? Is that right? You want to see the... All right, we'll let that download. Let's see if we can see the demon star. don't even know if it's up. Oh, here. So check this out. So it's got GPS satellites and geostationary satellites. So in theory, I can take pictures. I can look at images of satellites. So that's, they're just going to look like dots. But International Space Station? No. ISS? Yeah, there we go. So it's always below the horizon, which is weird to me. Wonder if Hubble. Nope. I think you can see the Chinese space station. I don't know why you'd want to look at GPS satellites. That's boring. All right, Algol. Rises. Yeah, it's up. We were pretty close to it. This is cool. This is a nice star. All right, let's get this new image of the double cluster. So the software that you're at, what software is this? Is the software that runs the Celestron Origin. So if you get the Celestron Origin, it comes with this software. So that is the double cluster. This is a very short exposure. 1. How are you able to see the Omega Nebula from the northern hemisphere? We just can. Like, it's not like we can't see below the equator. That is cool. So let's try a different, like a red star. But I thought Algol was like very yellow looking. It's just a very bright star. Yeah, so Celestron made software just for the Origin. And I kind of have a love-hate relationship with it. Like, what I love about it is it's very easy, it's very fast, it's very good for doing things like this with the virtual star party. But it's not very flexible, so I can't mess with it, which is what I want to be able to do. I want to be able to like pull the files off the file system. I want to be able to have more control over the telescope, and I'm kind of stuck. And in fact, it's kind of we're running a Mac Mini with the Celestron software running as an iOS app on the Mac Mini, and so it's like really not a perfect environment, but it works, and it's fast. And the pictures are good. So, the pictures that's really neat. But it should be yellow, right? Okay. Well, let's try like Arcturus then as a comparison, because that's a more red star if it's still up. No, it's already gone down. Okay, so it's 2200 right now, so let's see if we can see Crab Nebula now. So it rose 30 minutes ago. Nope, still too low. Okay, so let's try a longer exposure. Let's try the California. Yeah, is Alberio up? Okay, let's try that. Let's see if Alberio's up. I don't think it is. Yeah, it should be okay. Okay. Yeah, let's do it. Oh, and I was going to do the dumbbell nebula. So the camera is the one that's built into the Celestron Origin. It is like it's an all-in-one smart scope. So it does everything very quickly, very easy to use, but if you're a power user, you can't do interesting things with it. Like, normally there's this standard that telescopes use called ASCOM. And so you would be able to actually run a different controlling software. You can run all kinds of intelligence on your telescope, but you can't do that with the Origin. Fraser, did you hear the news that the sun will not go nova because it's not a binary star? According to the latest research, only binary stars can go nova. Well, yeah, that's not new research. You only get a nova when you have a white dwarf star that is feeding on a partner star, accreting material. Are we not pointing at Alberio? It's right there. Boy, it doesn't want to go there. There we go. Okay. Now we're talking. Oh, this is going to be good. Yeah, so in other words, to get a nova, you have a white dwarf star, like a dead version of the sun after the sun dies, and then a companion star. And the companion star or the white dwarf is feeding on material from the companion star. You get this ring of material around the outside of the white dwarf star, and then it detonates in a thermonuclear explosion, and then it starts the whole process all over again. And so the sun would have to have a partner that after the sun dies, turns into a white dwarf, then it would have to be able to feed on a partner star for it to be able to go nova. 30 seconds, that's enough. Okay, images downloaded. That's really great. So you can see it's the main star, and then there's a companion star right beside it. I have not done the North American Nebula. It doesn't look great. Like, we'll do the California Nebula, and then we'll do the North American Nebula, and we'll just do the North America. Sure, let's do that. We're very close. Jason, how is M33 Triangulum? It's in the list of images that I shared. Unfortunately, I can't make it say the file. So, the frustration with this telescope, right, is that it's storing the metadata for the images that it's taking, but then it is putting the images into the Apple Photos database and stripping off all of the metadata. And so I wrote a script that is then taking the images out of the downloads directory or out of the photo database and putting them into Google Drive just automatically. And what I want to do is I wanted to extract the metadata so that and then I would name the images Pleiades or, you know, whatever. But unfortunately, that metadata is not provided by the Celestron app. And I spent hours digging through the Mac file system and trying to figure out where this thing was storing its files. And I couldn't find it. So, but I've got a link up at the top that has all of the images that we've taken today. And I don't know which number was M33. It's one of them. Sagittarius is sort of too far below. We could point at Sagittarius A star. We could point at the supermassive black hole at the heart of the Milky Way, but we wouldn't see anything. So that's 10 seconds. You could just start to see a little bit of nebulosity. Yeah, this field of view is not big enough to show off the entire North American nebula. We should try the Rosette as well, obviously. Yeah, we could try the Bubble Nebula as well. But Evil Bonsai saying Alberio looks really cool to the eyepiece. Yeah, this is the kind of object that looks fantastic through the eyepiece. And we've also done Subaru M45. So you can start to see some of this nebulosity, and this is a minute. So it's not going to look great. Like if we wanted to actually show off the nebulosity, we're looking at an hour to do a really nice image of it. M81, M82, I think they're below the horizon. Yes. Mosaics. Yeah, so if I was like wanted to take my time, I would take one image of this, I'd take another image a little to the side of it, another image above it, and I'd download a whole bunch of those images, and then I would stack them up on the computer into one big mosaic image. But one, I'm not great with Photoshop, and two, you guys don't have time for that. But this is pretty nice. If we could see Sagittarius A star, how big would it look in the sky? Tiny. You wouldn't be able to see it. I mean, remember, like this worldwide collection of telescopes pointed at it and was just barely able to image the event horizon around it. So without a worldwide collection of radio telescopes creating a telescope the size of planet Earth, you can't see it. It's a nice picture. It's not a nice North American nebula picture, but it's a nice picture. You don't know what I have time for. All right, that's true. I don't know what you have time for. You clear up your schedule. We're going to make a mosaic of the North American nebula. No, it's not up. Won't be up for another hour. Too bad. So we're going to try the bubble. Okay. We can do the elephant trunk. That'd be cool. That's all right. That's worth looking at. And I really like all this dark material over on the left-hand side of the image. You know, these are molecular clouds that are dark, and so they actually obscure the view. It's not like we're seeing gaps in space where there are no stars. This is just that material's in the way, blocking our view to it. Let's Let's try the bubble nebula. That's the California. Yeah, we did catch the comet. I've taken some pictures of the comet before. And I could earlier in the night, like just when it starts to get dark, I take a picture of the comet. Well, maybe I could take a picture of the comet. It's moving higher and higher. Let me check. As soon as we're done with the bubble. No, can't see the emu. The emu is a thing seen from the southern hemisphere. All right, there's the bubble nebula. Stop that. Let me see if I can see the comet. Yes. Yeah, okay, we'll see the comet. Whoa. This is pretty cool. So that's the bubble nebula. You can see the bubble shape here. It looks better in longer exposures. So let's reframe it. The Emu constellation is, it's like a dark nebula that's visible in the Milky Way and seen from the southern hemisphere, I think. No, we can't see the remnants of the Apollo missions on the moon. Even the Hubble Space Telescope couldn't see that. You really can't see that until you go into orbit around the moon. But if you do a search for LRO, the Lunar Reconnaissance Orbiter, and then Apollo, like LRO and then Apollo, you'll see images of all the Apollo landings taken from orbit at the moon, which is pretty cool. So much worse. It was so much better like a week ago. So the comet is definitely getting worse and worse. Do I want to start again? Looks a little streaky. Yeah, I'm going to start again. The planet one would be more interesting, like the planet telescope. Yes and no. Like it would be fascinating to see Saturn and Jupiter, and we could see the great red spot on Jupiter, and we could see the moons going around Jupiter, and we see the bands on the planet. Saturn, obviously, we see the rings. Mars, we can see the polar ice caps, and then the moon. We can see like lots of different craters on the moon, and the moon looks different depending on the night. So the shadows change every night on the moon, and so different objects are featured on the moon. But it would get like, they're cool, but there's like 5 things to look at with a planetary scope, while there are 5,000 things to look at with a deep sky, one that can see like a wide field, do long exposures like this. So yeah, this telescope is doing the stacking live on board. So it's taking away a lot of the intelligence, or it's doing a lot of the heavy lifting here. Like normally in the olden days, I would have to download all of the separate raw images, and then I'd have to stack them up in nebulosity, and then I would have to mess with the brightness and contrast and then share the image. And now I don't have to do any of that. I just let it do it on its own. Thanks, Jason. The Horsehead Nebula is not up yet. It's in the constellation of Orion, and we need to wait another couple of months before Orion is visible in the evening sky. Okay. Let's stop that. I think this will be the last picture. Yeah, I could get a picture of Ceres. Let's see. But it's just going to look like a dot. Yeah. Here. Oh, too low. Okay, picture has arrived. Yeah, so we did look at Andromeda. There's a set of images I've pinned at the top where you can download all of the images that we've taken tonight. There's the comet. And it is so much worse than it looked like 5 days ago. Have we looked at the double cluster yet? Yes, we looked at the double cluster. So all of the pictures that we looked at, they're all in that link that I pinned at the top. This is tonight's images. And so I'll try and do that every week. So this is, again, just an experiment, just a test. The new improvement is that we've got me in a little corner, me in a little ring down at the bottom, and then we've got the live view down in the bottom left-hand corner. And I was trying to keep the names of the comet, or the names of the image up there, and we got most of the screen is dedicated to the image. So I think the design looks a lot nicer than it did earlier, the last one that I did. So we'll keep tweaking it. I think the next improvement that we're going to make is try and bring on a guest. So we'll figure that out as well. All right. Thanks, everybody. Super fun. We'll probably do this in a couple more days. Like, we're going to be doing these pretty often until I feel like we've stabilized the technology. And then we'll do this on a regular basis, probably Sunday nights, the way we used to on the old star parties. Okay. Thanks, everyone. We will see some new Space Bites tomorrow. And lots more content coming your way. All right. Thanks, everyone. We'll see you later.